All right, so given this equation, if 50 grams of zinc is reacted with 20 grams of sulfur, determine the limiting reagent. Okay, so anybody remember how I would go about doing that? How am I going to determine, or what is a limiting reagent? Let's start there. Yes.
It's the ingredient that runs out first.
That's right. It's the one that runs out first. So therefore, it will determine how much product, zinc sulfide, I make in the end. Because the one that's in excess is simply going to, there's going to be more of it left over, okay, in the end. So we need to figure out which one, either the 50 grams of zinc or the 20 grams of sulfur, is going to determine this final product. So if I want to find out how much zinc sulfide I make, I have to know which one to start with, because I have two options, either 50 grams of zinc or 20 grams of sulfur. So to determine which one to start with, I take just one of them. It doesn't matter which one, either the 50 grams of zinc or the 20 grams of sulfur, and I determine how much of the other thing I would need to react with it. So let's just go ahead and choose the 50 grams of zinc. Okay, so 50.0 grams of zinc. And is this a balanced chemical equation? Yes, it is, right? It's balanced, so I can use it. If it wasn't balanced, I would need to balance it before I could do the stoichiometry. Okay, so we want to determine how much sulfur is going to react with the zinc. So first thing I have to do is I have to convert it from grams of zinc to what? Moles of zinc. Because I cannot perform the stoichiometry if it is in grams. It has to be in moles. So that's my first step. After I convert it to the moles of zinc, I can now convert it from whatever it is to something else. What do I want to change it to? I want to go from moles of zinc to what? Moles of sulfur. But I cannot compare grams and moles to one another. So to be able to figure out which one is the limiting reactant, I need to convert it in the end back to grams of sulfur. Okay, so I like to write my process along the top. And then all I have to do is drop my units, grams of zinc. I just drop everything. Moles of zinc, moles of sulfur. And now I have it filled out. Once I have it filled out, I can put in all my numbers once I put all my units in, because it will tell me exactly what goes where. So moles to grams, whenever I have a gram to mole conversion, I want to know how many grams there are for every 1 mole. Okay? So I'm going to say grams of moles. Moles are always 1. Okay? Grams of moles. Moles are always 1. And then that grams of zinc, where do I find it? Good. I find it here. 65.38. Grams of sulfur, where do I find that? Here as well. Okay? Now, whenever you have a mole-to-mole relationship, that is a stoichiometric relationship. Where do you obtain stoichiometric relationships? The balanced chemical equation. This one's really easy because it doesn't have any coefficients. That is not usually the case. But this is just an easy, simple example. So because the coefficients are 1, they have a 1-to-1 relationship. Okay? 1 mole of sulfur for every 1 mole of zinc. That's how they're going to react. Okay, so 50 times 32.06 divided by 65.38. Who has that for me?
0.765.
That can't be. 24 point what, I'm sorry? 518 grams of sulfur. Okay? So 24.518 grams of sulfur. How many grams of sulfur? So This number is what? Is the amount that I would need to react with the 50 grams that I have. How much sulfur do I actually have? I only have 20 grams. So what does that mean? Sulfur is the limiting reactant. Which one is the one in excess? Zinc. Okay? That's how I find my limiting reactant. Now, it doesn't matter which one you start with. You could have either started with the zinc or the sulfur, and you would have got the same answer, just in a different way. So let's just look at how that is. So 20.0 grams of sulfur, and I want to go to the grams of zinc, so to the moles of sulfur, to the moles of zinc, to the grams of zinc. Drop my units, grams of sulfur, moles of zinc. Okay? So I drop everything, I fill it in. 1 and 1 for the moles, 32.06 grams of sulfur. There are 65.38 grams of zinc for every 1 mole, and it's a 1-to-1 relationship. So 20 times 65.38 divided by 32.06, what is that?
40.79 grams of zinc.
Okay, so if I have 20 grams of sulfur, I would need only 40.79 grams of zinc to react with it. But I have 50 grams. So do you see how we can figure out which one's limiting, which one's excess? Either way, it doesn't matter which one I start with. Okay, this is telling me it's an excess because I only need 40.979 and I have 50. So that 50 grams is in excess. If it's in excess, that means this 20 grams is limiting. Okay, so now that I've identified which is my limiting reactant, the reason I did that was so that I could figure out how much zinc sulfide is produced. Okay? So when I do that, when I'm going to figure out how much zinc sulfide is produced, what do I start with? How much sulfur?
20 grams.
Good. 20 grams of sulfur, because this is what I see a lot. People will give me the 24.518 grams of sulfur and start there and go on. That's not how you do it. Okay? This is just a theoretical amount. That's not how much I actually have. That's just how much would be used if it reacted with 50 grams of zinc. This is a calculated theoretical amount. The amount I actually have is 20 grams of sulfur. So to find the answer, to find out how much zinc sulfide I make, I need to start with 20.0 grams of my limiting reactant sulfur. Grams of sulfur to the moles of sulfur to the moles of zinc sulfide to the grams of zinc sulfide. Drop my units, grams of sulfur, moles of zinc sulfide. Grams of moles, moles are 1. Grams of sulfur are 32.06 grams of sulfur. And then zinc sulfide, somebody 32.06 plus 65.38. What do you get? 44? Okay. Once again, the coefficients are 1 for my balanced chemical equation. So 20 times 97.44 divided by 32.06. How much zinc sulfide in grams are produced in this reaction? Say it again. 60.79 grams of zinc sulfide. Okay? All right. So that's my answer. So from 20.0 grams of sulfur, I am going to produce 60.79 grams of zinc sulfide. Okay? Now, let's look at our questions here. If 50 grams of zinc is reacted with 20 grams of sulfur. Determine the limiting reactant. Sulfur. Okay. Determine the number of moles of zinc sulfide produced. 60.79. Okay. Oh, moles. Oh, did we skip that? Whoops. 60.79 grams of sulfur. Okay, it's not 1 mole. No. Let's just go back and do 20 divided by 32.06. What is that? That's just this first part. That's where we would stop for the moles of zinc sulfide. What was that one?
0.62. Yeah, 0.624.
Okay. So if I had stopped there, I would have found the moles of zinc sulfide, right? But if I keep going, I find the grams of zinc sulfide, which we did in the end. So 0.624 moles, 0.624 moles of zinc sulfide. Okay? Now, determine the number of grams of excess reagent left over in the reaction. What are they talking about? The zinc. The zinc was in excess, right? Did I use all of it? How much of it did I use? I used 40.79 grams of zinc. How much is left over? 50 minus 40.79. 9.21 grams of zinc. Okay? So the only way I could have done that, answered that question, is if I had determined how much zinc would be used in the reaction. So if I had done this one for my limiting, to determine my limiting, I would have had to do this one to determine how much zinc was actually used in the reaction. Okay?
Wait, how'd you get to 9.2 again?
Okay, so if I start with 20 grams of zinc, I will need 40.79 grams, of sulfur. I will need 40.79 grams of zinc to react with it. I had 50 grams.
Oh, you just subtracted.
I just subtract those. That's right. Any other questions? All right. Okay, let's move on. Here's another one. If 50.8 grams of aluminum oxide is reacted with 20.4 grams of iron, determine the limiting reagent. Okay, so that's my first step. Determine the limiting reagent. How am I going to do this? What do I need to do first? Good. Good, you recognize it's not a balanced chemical equation. I have to balance that, right? Okay, not too bad, right? So I need 2 of these, and I need 2 of those. The oxygens are balanced. That makes it easy. So now we have coefficients, okay? All right, so now what do I do? Okay, so start with 50.8. Do I have to start with 50.8 grams of Al2O3? No, I don't. I could do it the other way. Okay, I could start with the 20.4 grams of iron if I wanted to. Doesn't matter. Okay? So we're going to go from the grams of Al2O3, and we're going to go to the what? Moles of Al2O3. From the moles of Al2O3, I'm going to do what? That's right. I want to know how much iron is going to react with it so I can determine the limiting reactant. We're just looking at the reactants, Al2O3 and Fe. That's all we're looking at right now. Okay? Now, when you look at these stoichiometric problems, what I hope you're seeing is that there's basically a side A and a side B to this. Okay? If I divide this thing in half, this is side A, this is side B, right? The grams of Al2O3, the moles of Al2O3 are on side A. The moles of Fe and the grams of Fe, they are on side B. Because in stoichiometry, the whole purpose of it is to be able to convert from one thing to another thing. Okay? There's basically not really any other kind of conversions like that. You can only do that if you have a balanced chemical equation and if you're using moles. Okay? If you keep that straight, that it has to be in moles, and that's when I convert from one thing to another thing, that's going to help you. Okay? Okay, so I drop all my units. Can somebody find the mass of Al2O3? Okay, grams and moles. Moles are always 1. And now I'm going to figure out how many grams Al2O3 is. We have 2 aluminums and 3 oxygens. Okay, now, what do I put here? The coefficients from the balanced chemical equation. What number goes on top? 2. 2 moles of Fe. What number goes on the bottom? For every 1 Al2O3. Excellent. Okay, that's where I find those. Grams of iron, 55. Okay, so 50.8 times 2 times 55.847 divided by 101.8. What do you get? Like that?
Yeah.
Grams of Fe. Okay, so if I have 50.8 grams of Al2O3, I need 55.737 grams of iron. Okay, so which is my limiting reactant? Iron, definitely, right? I only have 20.4 grams of iron. I need 55.737. So that means iron is limiting, and Al2O3 is in excess. Okay? So, next question. Determine the number of moles of Al produced. What do I do? I'm sorry, go ahead. Good. So I'm going to use iron. I'm going to use the amount of iron. So do I use the 55.737? No. I use the 20.4. That's what I have, right? 20.4 grams of Fe. That's the amount I'm starting with, okay? This is what determines how much product I make because it will run out and go to 0. And then the reaction will stop. So I'm going to take my 20.4 grams of iron and I'm going to go to the moles of iron. Then where? Moles of Al. Right? They want to know how much aluminum is produced. That's what they want to know. Okay, now what? I'm sorry? Okay, that's one step too many, right? Sorry, I tried to trick you and I did. Okay, don't do that last step, right? Stop right there because that answers the question. The question is how many moles of Al? Okay, how many moles of Al? So we stop right there. So 20 grams of Fe to the moles of Fe, from the grams of Fe to the moles of Al, from the moles of Fe. Okay? Grams of moles, moles are always 1. Grams of iron I find from the periodic table, 55.847. Moles of Al on top are what? 2 moles of Al for every 2 moles of Fe. Okay? So those actually will end up canceling. So they're not really going to need, we're not going to really need to use them in our calculation. So 20.4 divided by 55.847. What is it?
0.3652.
Okay? So that's how many moles of Al are produced. 0.3652 moles of Al. Okay? How am I going to answer C? Determine the number of moles of Fe2O3 produced. How do I start that one?
Was it 20.4?
I started with the same limiting reactant, right? It's the 20.4 grams that determines the outcome. From grams of Fe to the moles of Fe to the moles of Fe2O3. Drop my units. Grams of moles. Moles are 1. Grams are 55.847. Mole-to-mole relationships I find from my balanced chemical equation. It's a 2 to 1. I have 1 mole on top, 2 on the bottom. So 20.4 divided by 55.847 divided by 2. What does that come out to be? Okay, what are you guys getting? Say it again. Okay. Good. Okay, that's how many moles of Fe2O3 are produced. Next, determine the number of grams of Fe2O3 produced. Okay, what would I do differently to determine that? Or what would I do next to determine that? Just simply convert this to grams, right? From the moles of Fe2O3, I could continue that and convert it to the grams of Fe2O3 from the moles of Fe2O3. Okay? Grams of moles. Moles are 1. Where am I going to find this number? Good. The mass of Fe2O3 from the periodic table. So somebody find out what that mass is.
159.69.
Okay? 0.183 times 159.69. Say it again.
29.22.
Okay. So, if I have 20 grams of iron, I can produce 29.22 grams of iron 3 oxide from that, which is rust. Determine the grams of Al produced in the reaction. So just right here, right? Continue it on. Grams of Al from the moles of Al. So 0.3652 times 26.98. 9.85 grams of ale. Good. Okay, determine the number of grams of excess reagent left over in the reaction. What is in excess? Okay, the Al2O3. From the information I have right now, can I determine how much excess there is? Did I set up an equation that allows me to know how much? Okay. How much? Okay, actually I don't. I don't have it. Okay, sorry. I'm just okay. So I need to start with my 20.4 grams of iron and go to the grams of Al2O3 to figure out how many grams are actually going to react with that 20.4. Because I don't know yet. Because earlier when I figured out the limiting, I used the 50.8 grams of Al2O3. So I don't know how many grams of the Al2O3 are actually going to be used in the reaction yet. Okay? So we're going to go from the grams of iron to the moles of iron to the moles of Al2O3 to the grams of Al2O3. And whatever that comes out to be, that's how much are going to react. And then I subtract it from the amount I have, which is 50.8 or something. Yeah, 50.8 grams of Fe, moles of Fe, moles of Al2O3. Grams of moles, moles are 1. Grams of iron are 55.847. Grams of Al2O3 are 101.8. Okay. The coefficients are 2 Fe's for every 1 Al2O3. 20.4 times 101.8 divided by 55.847 divided by 2. What do we come out with? 0.49, I'm sorry, 59. Okay, now I can figure it out. Okay, so I have 50.8 grams. I only use 18.59 grams of that. So how much is left over? So I subtract the 18.59 from the 50.8. 32.21 grams of Al2O3 left. And my pen stopped working. Yo. That's interesting. It's time to stop. Okay. Left. Good. Okay. Any questions? Okay, let's actually, we'll come back to that if we need to. Okay, I think we're okay with that. Okay, so really quick, I want to talk about this, and then I actually have a worksheet I want you guys to work on so we can practice this stuff, okay? Theoretical yield. Theoretical yield is the amount of product that would result if all the limiting reagent reacted. Okay? The actual yield is the amount of product actually obtained from a reaction. And also theoretical yield is the calculated amount. It's the one that you find from the calculation. The actual yield is what you'd find in the laboratory. I run the reaction. I should have gotten 50.5 grams of product. I only got 40.3. That's my actual yield. Okay? So 40.3 is the one that I actually get in the laboratory. I should have gotten 50.5. Okay? So that's the difference between actual and theoretical. A theoretical yield is the one that we calculate, the product amount that we calculate. So a lot of times we have to determine what is our limiting reactant so we can figure out how much product is formed, and that's our theoretical yield. Now, the reason we want to know these is because we find percent yields. The percent yield is the actual yield over the theoretical times 100. Actual over theoretical times 100 will tell me the percent yield, how well this reaction was done. How well did I run it? Okay? And so here's some examples. So determine the percent yield if zinc sulfide formed is 50 grams of zinc reacted with 20 grams of sulfur to produce 45.5 grams of zinc sulfide. So earlier, didn't we determine, this is the same example, right? And we determined how much zinc sulfide was produced. So let's just go back and look at it. Zinc sulfide, we said that we produced 60.79 grams of zinc sulfide. So if I want to find my percent yield, 60 point, what did I say? That's good enough. Grams of zinc sulfide. Okay? It only produced 45.5 grams in the laboratory. Okay? So, to find the percent yield, which one's my theoretical? This one's theoretical. This is my actual. This one's theoretical. So, percent yield is A over T times 100. Actual over theoretical times 100. So I would take my 45.5 grams of zinc sulfide and put it over my 60.7 grams of zinc sulfide times 100. What is my percent yield? I got that from our earlier, when we had done this question, this actual question to find the theoretical yield earlier, that's where I found it. That's how much zinc sulfide was that we calculated to be produced. This is how much was actually produced according to this question. So what's my percent yield? 75%. Okay? Not horrible, but not that good. So I probably could improve my process of collecting or running this reaction somehow, okay, to make it better. We'd want to make that yield a little better, okay. So that's kind of how the percent yield. That's how we read it, like 75%, not so great. Maybe for some types of reactions, maybe that's actually excellent. If there's like multiple steps in it, then you might be like 75%, not that bad, okay. But if it's just a straightforward reaction, that would, that might be a really terrible percent yield. Okay, and we did this one earlier. If the mass of Fe2O3 produced after the reaction was 20 grams, calculate the percent yield. So we go back here, and we say our actual yield of Fe2O3, was 29.22 grams of Fe2O3. That's how much we theoretically produced. This is our theoretical. Okay, so we're going to take that theoretical, now that I forgot it, 29 point something? Sorry, I get to 29.22, okay. And we're going to use it here. So 29.22 grams of Fe2O3 is my calculated theoretical amount, and my actual is 20.0 grams. Okay, so A over T times 100 equals percent yield. So 20.0 grams over 29.22 Fe2O3 times 100. So what's my percent yield for this one?
0.6844.
Can't be point, has to be 68%? Okay, so just times 100. Okay, so 68% is my percent yield for this one. Okay, that's even worse than the other one. Okay, so that's how we do these percent yield questions. Okay, so before we get into, let's see, let's